In this lesson, we are going to be starting our work with complex numbers. A complex number involves a real number and an imaginary number. Complex numbers are always in the form of a plus bi. The a and the b are real numbers. B is the imaginary part, bi. Actually, it's mostly the I is the imaginary, but when the B is attached to it, it makes the whole part imaginary. There's really only two things that you need to know. The imaginary unit, the I, is the square root of -1. All along in your previous courses, when we would take the square root of a negative number, we would say that there is no solution, but there is no solution in the real number system. So I is the square root of -1. And then if we square it, in other words, we would multiply the square root of -1 times the square root of -1. Remember that that would be the square root of -1 squared. A square and a square root cancel each other. And so this would mean that that would be a -1 as our solution. So the imaginary unit can be used to find square root of any imaginary number. So the square root of 16 is 4, and the square root of -1 would be I. The square root of -3, the square root of 3 would be a decimal, so if we leave it just as the square root of 3, but the square root of -1 is I, so the I will come out as the coefficient. When we find the square root of 20, remember that we are making a factor tree to simplify 20. And so when there are two 2's that we use, the one of the 2's can come out, which is really the square root of 4, which is 2. The 5 is going to stay under the radical, and the negative sign will come out as the I. So in this lesson, we're going to be able to identify the real part and the imaginary part. So the real part is the 2. The imaginary would be the I, which is the 4i. 1/2 would be real. 6i would be imaginary. -5 is the real part, and the 2i is the imaginary part. When we solve equations using real and imaginary numbers, the first thing that we want to do is to take a look by getting the x squared by itself. That's called isolation. So we want you to isolate the x squared, get it by itself, and once we do that, we're going to take the square root of both sides. In the first example, the x squared is already by itself. So if we take the square root of both sides, remember a square and a square root cancel. So we have x equals plus or minus. And don't forget the plus or minus because we don't know if it was a positive or a negative. So the square root of 64 is 8. And then remember the square root of the -1 or the negative sign is I. So we'll have plus or minus 8i. In the next example, we're going to subtract 26 from both sides. So we have 2x squared equals -36. Divide both sides by 2. So we have x squared is equal to -18. And we're going to take the square root of both sides. And when we do that, a square and a square root cancel. If we make a factor tree for 18, it looks like the 3 can come out, so don't forget your plus or minus 3. The negative sign would be the square root of -1 is I, and then there's a 2 left under the radical. When we combine like terms with the i's, what we want to remember is that we simply combine the real parts. So -1 plus 3 would be 2. And then we combine the i's. 2i and 3i is 5i. In the next example, remember we're going to subtract each of these, and minus a negative would be plus. 7i. So if we combine the real parts, 2 and a negative 3 would be negative 1. And then negative 3i and positive 7i combined together would be positive 4i. In the last example of combining, remember we're going to subtract everything in that set of parentheses and then combine with the rest. So we have a negative 3 and a positive 2, which will be a negative 1, and a 2i and a negative 1i and a negative 3i put together would be negative 2i. As we perform more operations, the first thing we want to do then is to be able to use the distributive property. So when we're doing the distributive property, negative I times 3 would be negative 3i. And then remember, negative I times positive I is negative. I times I is I squared. But what we discovered was that I squared really means negative 1. So we have negative 3i minus negative 1. Minus a negative is a plus, and when we write our final answer, we always write the real part first. Whoops, forgot my I. And then the imaginary part. So it's a positive 1 and then minus 3i. Distribute in the next one, you have 2i times 4 would be 8i minus 2i squared. So I squared means negative 1. Negative 2 times negative 1 would be positive 2, and then put the 8i after. It's always the real part followed by the imaginary part. In the next example, negative 3i times 6 would be negative 18i, and negative 3i times negative 5i would be negative 15i squared. So remember, the I squared is negative 1. So negative 15 times negative 1 is positive 15 minus 18i, the real part followed by the imaginary part. Now when we get to the next examples, we're going to do the foiling like we did when we were in Algebra 1 with the distributive property where we take the first times the first. So 3 times 5 would be 15. The outside times the outside, 3 times 2i would be 6i. Inside times inside would be 20i. And last times last would be 8i squared. To simplify, remember that I squared is negative 1. So we have 8 times negative 1 is negative 8, plus 15 would be 7. And then a 6i and a 20i would be 26i. Distribute. 2 times negative 6 is negative 12. 2 times negative 2i is negative 4i. 3i times negative 6 would be negative 18i. And 3i times negative 2i would be negative 6i squared. I squared is negative 1. Negative 6 times negative 1 is a positive 6. Plus negative 12 would be negative 6. And then we have negative 4i and negative 18i would be negative 22i. In the last example, 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is 2i, and 2i times negative 2i is negative 4i squared. I squared is negative 1. Negative 1 times 4 is 4, plus 1 is 5. And then the interesting part would be that 2i and negative 2i are opposites, so they have a sum of 0. So our final answer would be 5. And that's an important thing to look at before we move on, is that these are called conjugates of one another because they're exactly the same binomial but differ only by the sign that's in the middle. One is positive and one is negative. When that happens with our imaginary numbers, you'll notice that after we are finished, that we have only a whole number remaining. We need to use that principle when doing our next examples because we cannot leave an imaginary number in the denominator of a fraction. So we want to multiply by the complex conjugate. The complex conjugate simply means that we take the bottom imaginary number and we change the sign in the middle. When that happens, we're going to multiply both the top and the bottom by the complex conjugate. And when we do that, that will help us to get rid of the imaginary number in the bottom, in the denominator. It does not change our number, but simply changes its form. So we'll multiply the top. 2 times 1 is 2. 2 times negative I is negative 2I. Negative 7I times 1 is negative 7I. And negative 7I times negative I is positive 7I squared. In the denominator, we have 1 times 1, which is 1. 1 times I, negative I would be negative I. I times 1 is I. And I times negative 1 would be negative 1I squared. So now we'll simplify. Remember that I squared is really negative 1. So negative 1 times 7 would be negative 7, plus 2 would be negative 5. Then negative 2I and negative 7I combined together would be negative 9I. In the denominator, we know that the negative I and the positive I will cancel. I squared is negative 1. Negative 1 times negative 1 is positive 1, and positive 1 plus 1 would be 2. So when we multiply by the complex conjugate, it helps us to get rid of the imaginary number in the denominator. So now we're going to multiply again by the complex conjugate. So negative 2 minus I. Notice it's the exact same binomial. We're only changing the sign in the middle. So 3 times negative 2 would be negative 6. 3 times negative I would be negative 3I. I times negative 2 is negative 2I. And I times negative I is negative I squared. In the denominator, negative 2 times negative 2 is positive 4. Negative 2 times I is a positive 2I. I times negative 2 is negative 2I. And I times negative I is negative I squared. Simplifying, remember that I squared is negative 1. Negative times a negative would be positive 1, plus negative 6 would be negative 5. Negative 3I and negative 2I would be negative 5I. In the denominator, the 2I and the negative 2I cancel. I squared is really negative 1. A negative times a negative is a positive, so 4 plus 1 is 5. Now we should also notice that when we're working on this problem now that each of these could be divided by 5. So our final answer will be negative 1 minus I divided by 1, which just gives me a final solution of negative 1 minus I. In the next problem, we are going to multiply again by the complex conjugate as 2 plus I square roots of 5. 2 plus I square root of 5, which is the exact same as the bottom, the denominator, but we've changed the sign. 3 times 2 is 6. 3 times I square root of 5 will be 3I square root of 5. I square root of 5 times 2 will be 2I square root of 5. And I square root of 5 times I square root of 5 is going to be positive I squared. And then the square root of 5 times the square root of 5 is 5. On the bottom, we have 2 times 2, which is 4. 2 times I square root of 5 is 2I square root of 5. Negative square root of 5, negative I square root of 5 times 2 is negative 2I square root of 5. And negative square root of I square root of 5 times a positive I square root of 5 is negative I squared, and then the square root of 5 times the square root of 5 is 5. Whew, so let's simplify. I squared is negative 1 times 5 is negative 5 plus 6 would be 1. 3i square root of 5 and 2i square root of 5 would be 5i square root of 5. 2i square root of 5 and negative 2i square root of 5 cancel each other. I squared is negative 1. Negative 1 times negative 1 is positive 1 times 5 is 5 plus 4 is 9. So would you please try the rest of the samples and let me know if you have questions.